Algebra, how are you? I am so excited to start chapter 10. As we get started, we're going to take a look at our chapter 9 test when we get back to class. We have 2 chapters left, so finish strong, only about 20 worksheets. I love you, but I don't want to see you this summer, not for school at least. So let's get things going. Chapter 10:1. We're going to talk about polynomials. So polynomials can be found in different ways: a monomial, a binomial, a trinomial, or a polynomial. So what do all of those mean? Well, a monomial is something with only one term, like x, or 8v squared. That's all one thing, but it's only one term, or 2. Monomials are things that are separated by a plus and a minus sign, okay? So there's no plus or minus sign with this x. There's no plus or minus sign with this 8v squared. There's no plus or minus sign with the 2. So that's a monomial. A binomial, on the other hand, bi means 2. Whoops, I didn't mean to change that, but that's okay. Bi means 2, so there's 2 terms, like x plus 3. It's a monomial plus a monomial. Or 4x minus 3y. So binomials are separated by that plus or minus because there are pluses and minuses in them. Okay? What about a trinomial? How many terms do you think a trinomial is going to have? Well, I'm hoping you said 3. And you should recognize this trinomial. This trinomial is called a quadratic. We've been doing a lot with quadratics in the last chapter. Okay? What about when you have 4 or more terms? It is called a polynomial. Poly means many. And so many terms is a polynomial. So it's 4 or more. Okay? All right, great. So we've got a couple different things we want to talk about. So when we're talking about polynomials, we're looking at how big they are. Okay? And that is defined by our degree. Our degree is told by our highest exponent. So there's 0 exponents, theoretically, because there's an imaginary one on here, but there's 0 exponents on a constant, right? So the number 4 is graphed as just a point, right? So if I am looking at that, if I'm looking at a linear polynomial, makes a line, I've got y equals 2x plus 3. What's my degree here? Well, the exponent on my variable, it has to be on a variable, is 1. And so that makes a linear polynomial, okay? And it makes a line. And then last chapter, we talked about the quadratic specifically. And the quadratic had an x squared term in it. And then often an x term and then a constant. This one doesn't, but that doesn't make it less of a quadratic. If it's got an x squared term, it's a quadratic because my degree of my exponent on my variable is a 2. And we know that that is graphed like a parabola, okay? So that is one of the ways that we can classify polynomials. We're not going to do a ton of classifying, but we are going to do some, and we're definitely going to be talking about quadratics. Okay, so monomial, binomial, trinomial, polynomial is all going to give us a classification, and then we can classify also by degree. Okay, so number of terms in this guy, 3x squared plus 5. There's 1 plus sign. How many terms are there? There's 2 terms. We would classify that as what kind? That would be a binomial. On your work, you can put bi down, or you can spell out the word. Okay? what's the shape of this graph? It's a squared term, so we know that that is a parabola, okay? Now, for y, what's my number of terms? How many terms are there? There's no plus sign, there's no minus sign, so there's only one term there. So that would be classified as a monomial. We're going to do mono for that one. Monomial. All right. And that would be linear for sure because there's a y in there. So y equals mx plus b. We have a ability to graph an intercept and things. Here I've got 18. 18 is how many terms? Well, it's got one term, of course. And that is also going to be a monomial. Again, you can just put mon or mono for when you're doing your work. And then the rest of the word is monomial, okay? So how would I graph 18? Well, it would just be a point. I think we'll do this next one together in class. All right, let's look at this. So as I am talking, I am thinking like terms when I'm adding polynomials. So here I have a polynomial plus polynomial plus polynomial plus polynomial, right? Okay, so I need to find what I have for like terms. So here I have 3x squared y. Do I have any other x squared y terms? I do. Here I have another one. Okay, and here I have one more. All right, am I able to combine those because they're like terms? I sure can. So I would combine all three of those. And how am I going to combine those? What am I going to get? I'm going to add my 3 plus my 2 plus my 2 and get 7x squared y. All right. What about my next term over here? This right here is not an x squared y term, it's an xy squared term. So it's just all by itself. So it just comes down, it's positive. So I just add my xy squared. So I'm going to add the coefficients, the numbers in front, of my monomials to get how many totals I have, and I can do that because they are the exact same variables with exponents. So exponents are the same, the variables are the same, and everything is the same. Look at this one down here, 3x plus 1 plus x minus 2. What's the same? Well, let's see. I've got a 3x and I've got a x, okay? I'm going to add these together so I can do my 3x and my x, and I will get 4x because there's an imaginary 1 in front of that. And then I've got my 1, and I have a negative 2. Are those both constants? They are. So then those can get added together. 1 plus negative 2 gives me negative 1. So my final answer here when I'm adding those together is 4x minus 1. So basically, we're combining like terms. So one of the things that we can do is find those like terms and box them out like we did. X squared and an x squared term. Okay? And I'm adding those together. There's 1 here and 1 here, so how many do I have all together? Well, I have 2 x squared terms, okay? What about x terms? Here in this quadratic, I have 2 x's in this one, and I've got 2 x's in this one. Probably wanted to change my shape. I do. I want to change my shape. I want to make that a circle. Because if I don't have colors, I can change shapes. So my 2x and my x will give me how many x's all together? Because there's 1 in front of here. It gives me positive 3 x's. Okay? So now I've got my plus 3 and my negative 2, I can combine those together. 3 plus negative 2 gives me positive 1. And that's my answer. My quadratic that I get from that is, by adding these two quadratics together, I get one quadratic. What kind of polynomial is this? It's a trinomial. And what would my graph look like? It would be a U. One quick note that I'd like to make is that when we do x plus x, it does not equal x squared. X plus x is taking one x in one hand, one x in another hand, and how many x's do I have altogether? I've got 2 of them. X squared is the result of x times x, not x plus x. All right, number 2, and we'll do 2 together. No, 2 and 3 we're going to do in class. 2 and 3 we're going to do in class. So, God bless.